Welcome, everyone. My name is Ryan. I hope you've enjoyed Buffalo Startup Week so far. I think I'm either the last or the second to last talk of the entire week. So everyone who's here, thanks for coming. I know it's Friday, end of work hours. So just a little bit about myself. I'm a software engineer at a company called in San Francisco called Second Measure, but I used to live in Buffalo for about 7 years. And I worked at ACV Auctions, in fact, for some of that time. So jumping right into it, one of the biggest challenges in any tech company, small or large, is converting the vision of the product into actual software. If you're a non-tech person, a project manager or a CEO, or someone who wants to start something, you've probably experienced this. You have this amazing idea that can make millions of dollars. You hire these brilliant engineers to execute your vision, and you explain to them what you want to build in what you think is excruciating detail. Months pass, and the app is near completion, and you finally look at it, and it's not the app you envisioned. It's something completely different, and you scratch your head and you wonder what went wrong. You ask your engineers what happened, and they tell you, well, we built exactly what you asked for. Now, this is a tale as old as time itself, and you've probably encountered this in one form or another, whether it's a new feature at your company or you're building a whole application from scratch. The reason this happens, basically, is because product and tech are speaking two fundamentally different languages. So while the product owner has this mental model of the app, that mental model doesn't always translate well into a database model or a user interface. So what if there was some sort of framework or some kind of common language that both product owners and tech could understand, and they could use that to develop a product together and communicate their ideas effectively? So today we're going to talk about a process called schema-driven design that can help you do exactly that. Now, this process isn't exhaustive. It's not a silver bullet that will fix all your communication issues with your team. But it's a really good starting point when you're just past the ideation phase and you really want to start building something. So schema-driven design. What is schema-driven design? So it's a process to sort of organize your ideas into basically 3 categories and document them in a way that your engineers can use later. So product people often think in terms of user experience and user stories, while engineers think in terms of data. So we basically need to think about the user experience and figure out all the pieces of data we need to know to make that user experience happen. So let's say you're making the next big social media platform, right? Let's keep it simple. So let's say users can make posts and they can follow other users. So you can imagine like any social media platform like Facebook, you can make some posts and some people can follow you, you can follow other people. So we want to identify 3 different categories of data in this user story. These are entities, relationships, and actions. And I'll kind of explain them as we go through them. So in our user story, we have users and we have posts, right? And these are our entities in schema-driven design. These are the things that make up our application. So next we can identify some relationships between the entities. Every user has a list of followers. They also have a list of people they're following. Users also have posts they created. So we know those 2 things are related as well. The actions are the things any entity can do. In our case, it's really just the users. The posts won't really be able to do anything. But it's the actual things they can do. So they can create a post or they can follow another user. So now that we've defined those 3 things, we can create a schema that sort of systematizes these concepts for an engineer. And I'm going to show you that process using a GraphQL schema, you don't need to know what that is, and you can actually use something else if you want. There are a ton of ways to sort of document this kind of data in a very simplified code, semi-code way, and you don't need to use GraphQL, but that's just what I'm using here, and I would strongly recommend it. Let me F5 out of here. Let me quickly go back. All right, let me reshare. Screen 3. Y'all can see that?
Yep.
Okay. So what we're going to do is try to kind of take that, those concepts we kind of systematized into words and kind of put them into a format that is a little more understandable by engineers. Again, this isn't going to be universal or work for every engineer, but it's again a good starting place for this kind of work. So in GraphQL, it's pretty simple. Anyone who's an engineer here is probably familiar with JSON, the JSON format. And so for non-engineers here, should be relatively simple to follow, and I'll kind of walk you through what's going on. So I'll write some stuff and I'll kind of explain it. So we're going to find 2 different types. These will be our entities. Whoops, where did I write that? Okay, that was weird. Type user. Insert node. What's going on? I don't know what's happening. Live coding, guys. You gotta love it. Okay, there we go. I don't know why that worked. Okay, so what we have here, we're just defining the name of this thing. Again, we said user was one of them. Post is another. So one thing I didn't really talk about was when we define these entities, we kind of want to flesh out what information is relevant to any of these different pieces of data. For example, like if you're a product person, do you want, every user has a name, right? Like, do you want to record full name? Do you want to record first and last name? A million ways you could do it. The engineer doesn't necessarily know, but those things are important because changing it later will be a huge pain. So let's just say for now, yes, this person has a full name. And we're going to give it a type of string. So string for non-engineers is essentially just text. For us, it would look something like, I don't know if this will let me do that. So this guy's name would be like John Doe. That would be a string, as opposed to a number, which you'll see later, most likely. We'll also have an ID. You don't need to really worry about that if you're a non-tech person, but for engineers in the room, this person will also probably have some sort of unique ID, as you might imagine. Full name, email, also a string. And just to demonstrate some of the other types we have in here, you might have like, is this user like disabled or like or active? So we might say false because the user's still active in the platform. And maybe later, or sorry, this should actually read Boolean, which can be either true or false. This is just a comment right here. Yeah, this is just another example of what you can do with this data and the kinds of product decisions that need to be converted into some kind of code that the engineers can use to start building the application. Again, it's not an exhaustive list of all the information they would need, but it's a good starting point. It's better than just saying there should be users and they need to have a bunch of information on it. This is a lot more precise and closer to the kind of data that engineers are working with. Let's go on and just define some basic things about post. Post will have like text. That'll be a string. It'll probably have an ID. Again, not important for non-tech people. And this is probably all you really need right now. So these are the sort of atomized pieces of data that we have right now. These are just the entities on their own. The next thing I want to define are the relationships between these things. So a user will have, maybe I'll start with the relationship between users and other users. So they have a list of followers. The type of this is, does anyone want to guess? Anyone want to make a wild guess?
List of users?
Yeah, there it is. It's going to be a list of users. The way we denote that is with these square brackets. If you're a program, you'll be familiar with the square brackets referring to a list or an array. In this case, we're going to define it like this. It'll be a square bracket with the word user inside of it. So yeah, our followers are going to be a list of other users. Following, so these are the people that the user themselves would be following, would, as you guessed it, also be a list of users. The next piece of data thing we want to define, the next relationship, in other words, we want to define on here is their posts. And these are the posts they've created. Posts would be a list of posts. And this is actually directly referencing the actual type of post in GraphQL. Again, there are other ways to document this, but in a GraphQL schema, this is how you do it. And so we know that users related to post, that relationship can work both ways. We can define this as, we could either say user, but from a product standpoint, it might make more sense to actually call it the creator or something of that sort. So the creator is also going to be a user. So these things can refer to each other in both directions. So those are kind of our relationships between the user and the post, and users and users. And obviously this is a very, very small basic app. There'd be a ton of different things you'd want to define. But here's where maybe it gets a little more complicated. So actions. So it's all the things that, in this case, all the things that the actual user can do. So excuse some boilerplate. Actually, I don't know if it'll let me do it like that. This might get a little mad at me, this editor, but that's fine. I probably should have done this in VS Code, but we're gonna write in GraphQL what we call a mutation. If you're a programmer, it's basically just like a function definition. And this is kind of and for non-tech people, this is the way we'll sort of define any action that the user can do. So actually, let me try that one more time. No, it's not going to let me do that. Yeah. Oh, wait. Idiot. It'll let me do that. Okay, so ignore this for right now. That's just something you have to put there. So what are some of the actions our user can take? So what was it? They can create a post and they can follow another user. Okay, so user can create a post. We'll call that create post. Okay, what kind of information might you want to know if you're trying to create a post? Anyone can call out. What information do you need to know to create a post?
The current time.
Well, we could probably do that automatically. I mean, we could probably find that automatically, but I suppose you might want to know the current time. Editor is doing things, man. We can just make that a string. String. Can I expand this? I can. Anything else we'd want to know about and maybe something about the post itself?
The text.
The text of the post, precisely. Text, that'll also be a string. Well, there's one other really crucial thing we'd need to know. Any guesses?
Who made the post?
Who made the post? We'll keep it simple and just say user. Technically, this will probably have to be user ID. We can just say user. That's totally fine too. Just for the purposes of this, an engineer would probably be able to figure out exactly how to reason about this. So this is one of the actions we need. This is important. Defining all these things is important because this, for an engineer, would have to be some endpoint or some piece of business logic that have to figure out on the back end they've created. They need to know exactly what's getting passed in and exactly what would get passed back. In GraphQL land, every mutation has to return something. We'll just return the post itself. That's not super important. There might be product reasons you might want to return one thing or another. So let's say you want to create a post, and for your product, you decide that you want to return some success message or some such thing. You could just as easily do that too. You just have to define another type for that. But those things are important. You want to make that clear to your engineers beforehand and define exactly what information you want to pass to the user. Again, this method is to reduce ambiguity. This is very, very explicit. And it can be a little tech heavy at the beginning, but in my experience with working with people, non-technical people through this process, I found you can catch on pretty quickly to how this works. And even in some cases, write some of the schema themselves. Very basic things, but you know, I think it's simple enough to understand. Probably the most complicated part is the the action part. So let's just create the last or the second action. Really, just the only other action there is, which would be follow user. So what information do we need to follow a user? Well, what do we need to know?
The user who you're trying to follow.
Okay. What do we call it? What should we call the parameter? What should we call that piece of data? This is an open-ended because there's no right answer. This is
User to follow.
okay. Oops. To follow user. And then the second one will just be, like in create post, we need to know who's doing the following. So follower, following user, something you can call it. These are good questions for an actual product person who's thought about these things. And this is where the limitations, where you kind of meet the limitations of what an engineer can and should do. Obviously, as an engineer, part of your job is good naming conventions, but you know, presumably these are the conventions you'd follow throughout your application. And it's why it's important to sit down with a product person to figure those things out. User, and you know, we'll just return like, we'll return the user that that we're following, that we end up following. What's that about? Yeah, that's fine. Okay. So far, what we've done, just to recap, is we've defined the two things in our basic social media app that make up our application. We had a user and a post. It could be way more expansive than that, but we've chosen this really simple, this simple version. Next, what we did, we fleshed it out with a couple of pieces of information like name, email, the text of the post, really basic things like that. The next step was to define those relationships. How might user and post be related? So does a user have followers? Okay, well, what type is that? It's another user. We define those things in our schema. Same thing with a post. A post has a creator. That defines the relationship between the post and the creator. The creator would be the user that created that post. The last step was to define all the actions any user can take in the application, or really any entity. For example, you could have another app, not a social media app, where there are not just users, but there are other entities like a company or a group that could technically take a certain action. Obviously, it's customers and real people sitting behind the computer doing those actions. But for the purposes of the schema and defining a really precise model for your application, yeah, it's really defining the actions any entity can take. In this case, it's a user, and in most cases, it'll be a user. And so we defined those two things, which was creating a post and following a user. And we defined what are the things we need to know when we're creating the post. Well, we need to know the text. We need to know the user who's doing it, who's creating the post. And Liam pointed out that we could also pass in the current time if we wanted to track that. If that were the case, we'd probably want to add that field actually. Created that. We can make this a string, although you can do date time. And the last thing we did was create a follow user action to represent any user following another user. So that sort of forms the basis and the majority of what schema-driven design is. There are several ways to go about it, but the things we've laid out are sort of the fundamental building blocks of almost any application. Again, this isn't going to solve this schema definition, made by a product person is not going to answer all the technical questions of an engineer. There are still going to be difficult technical problems to solve as an engineer, but that's not really the point of this. The point is to communicate effectively and have sort of a common language between product and tech, because so often the product people say one thing and the engineers create something else. So I hope this was a good, at least, intro into what this kind of process can look like. I strongly encourage you to sort of adapt it to what you need. I think the broader concept of creating a code-like schema for engineers, I think is a really important one. Again, how specifically implemented isn't important. I use GraphQL. You can do that however you like. And I strongly recommend GraphQL. I think it's really made well for this kind of thing. But yeah, that's kind of the basis of schema-driven design. I'm going to open up for any questions. But other than that, we're done, and thank you for coming. Any questions?
I kind of have one. So,
Sure, go for it.
You let answer Jonathan's first real quick.
Oh, okay. Wait, is it
It's in the chat.
Oh. Chat. Can you execute it? Do you mean, can you execute the, what exactly do you mean by that? Execute what, I guess? Execute what I just created? So what I can do, this actually probably will break because of the syntax errors I have. Let me actually comment this out. Specifically GraphQL editor, this thing, what it'll do, it'll create a diagram for me. Oh, it has comments in there. That's funny. It'll create a diagram for me. This won't actually run any code. This needs some actual, even a GraphQL schema in an actual code base needs some actual business logic behind it to do something. Again, you could think of this less as code and more as just a manual, a guide for, you know, building an app. So, you know, obviously this doesn't reflect a database model necessarily. This reflects what one would call a view model. It's the front end model. It's the data the user gets to see. It doesn't reflect your SQL tables, your Mongo documents, nothing like that. So yeah, it can't really be executed. No. Good question, Liam. You got a question?
Oh yeah. So I was curious. So if like a product team comes to the engineering team with this fully flushed out schema, and then the engineering team builds out half or 75% of it, and then product decides, oh, we want to make some changes. They make some changes, they give it back, but the entire thing's changed around. Like,
Yeah, so
I guess this doesn't really help in that scenario, right?
So I think I might have forgotten to mention this. This is a process that should be done with both product owners and the engineers. So, and in my experience with doing this with product owners, yeah, it was both of us together. To the best way to do it is like you kind of have your like main product owner and like your lead engineer kind of lead the discussion. But basically, the product owners will kind of spit the ideas out. The engineers will sort of convert that into the actual code. Like, again, a product owner's they don't really need to know what a string and what a Boolean is necessarily. Though I think it's, again, simple enough to understand. So in the case you're talking about, presumably this has been done with the product owner and the engineer already. So the engineer has already given pushback on what works and what doesn't. Now, in the case that like, something doesn't work out technically and you need to go back and change it, that's certainly possible. But that's really like any application, right? I mean, the requirements change. I think systems like GraphQL are pretty tolerant to change generally because everything's well defined, so you don't get a ton of errors trying to grab things that don't exist. But yeah, I would say that's almost that's a problem you can run into anyway. At the very least, if that does happen, at least you have some original document to base your changes off of, instead of basing them on nothing or restarting like totally greenfield. Yeah, but That's a good question. Did that answer your question?
Yeah, it did.
Okay.
Thank you.
Okay. Any other questions? Okay. I think that'll just about do it. This went pretty short, which is good because it's Friday afternoon. I hope you enjoyed Buffalo Startup Week, and I hope you enjoy your weekends. Thank you very much.
Thanks, Ryan. Thanks everyone for coming.